Okay. So I'm going to talk about mesh networking. If any of you have been coming to this for a long time or used to go to London Arduino, you may have seen me talk about a previous generation of this stuff that I've done. And it's a little bit of a pet hobby horse kind of thing for me because there's reasons. And the reasons I play around with mesh networking is a lot of my hobby stuff is involved in being outdoors. And being outdoors in large areas, and trees are evil. Trees are absolutely evil. If you're trying to do any form of wireless networking outdoors, you're trying to do it on uneven ground, hills are evil. You ever try, you think about, okay, I can't get a wireless signal at the end of my garden. Imagine doing this in a great big massive space outdoors with loads of people all moving around. You've got almost no 3G and 4G reception. People are moving around. You don't know where you're going to put the things beforehand. There's no mains power. You can't have a massive antenna like 100 foot up in the air and any of that stuff. So if you want to make things talk to each other out in the real world, out in a wood somewhere or a large sort of like complicated area in the real world, it's hard. And that's why I've tried to do a mesh network before. And the reason I'm doing that is because then everything can talk to everything else and relay traffic for everything else. So there's no central point to talk back to. Now, in the past, I did a mesh solution based on some data radios that you can't buy anymore. It was a really nice solution. You just can't buy it anymore. The company went wrong. They don't make it. It worked quite well, but it was expensive. And what I wanted to do is, for my next project, it needs to be super mega cheap. So what I've gone with is I'm using something which a lot of you will have heard of before, which is the ESP8266. These are £2. If you buy these from China, these are £2, and these things are tiny, absolutely teeny tiny, and they'll do quite a lot. So you've got 160 megahertz processor, 80k of RAM. There's tons of support in the open source community. There are similar things as well, so Nordic do a similar chipset. If I was going to do this properly for a small number of things with a decent budget, I would be using LoRa. But I've got almost no budget, and I'm doing it for 40 plus things. And when you want to make 40 plus things, if the chip costs a tenner, that's 400 quid. If the chip costs 2 quid, it's 80 quid. And that makes a massive difference on the project that I'm talking about. So I've kind of ended up with, this is about the cheapest thing I can buy. How am I going to do it? The problem is there was very little choice. If I wanted to come up with a mesh network solution using microcontrollers and Wi-Fi things, there's not a lot of choice. Almost nothing out there. There are some people who've done some stuff with an open source project called Painless Mesh, which claims to be painless. It's not desperately painless. It's actually a bit of a pain in the neck. It scales poorly. It uses a lot of resource. When I built some nodes to use it, I managed to get to 12 before it started to fall over. It uses TCP connections between the nodes. Each of them pretends to be a wireless access point. They all connect to each other. There's almost like a little network of, I don't know, peer-to-peer sort of computers like you would normally connect to a Wi-Fi access point. It's fine, but it just doesn't scale. The range isn't great. It's all just a little bit flaky. There is, from the people who make these chipset, a library called ESP-Mesh, which they released, and I thought, that will be fantastic, I'll use it. However, they only really support it properly on the later version of this, which is called the ESP32, which is slightly more expensive, but more importantly uses about double the power, and all my stuff is going to be powered off batteries. It makes a big difference. And it is very much based around being an IoT project. So the idea is that you set up this ESP mesh stuff with all their product, and then somewhere there's a central access point that they can connect to, and there's like a master controller that decides who's on what layer, and the stuff doesn't move around, and all the links are kind of static. So it's essentially a fantastic range extender. It's a way of saying, okay, we're going to spread our mesh out a bit longer, and we're going to use this thing for it. So the idea is you'd have something that connects to your home Wi-Fi router, you'd have some sensors around the house, could be a video camera, could be something like that, and it's a way to make that work a bit better, but it's not really a standalone solution. It's something you bolt on to something else. And what I really wanted was a standalone solution where everything can talk to everything else, everything is equal, nothing is in charge. So I started to have a look. I went, how am I going to do this? There are limitations on these little Wi-Fi chips. They're not big. They can't handle many connections. If you set them up as a wireless access point, you can only connect, I think, 4 or 8, depending on how you set it up. You can't have many connections. And when you actually start sending TCP/IP packets back and forth, you can't have many connections open. It's all very limited. Now, one thing that ESPRESSIF, the company who make these, do is they released a library which is specifically meant for allowing these things to talk to each other without having all the complexity that you would normally have if you've got, say, a laptop talking to a Wi-Fi access point. It allows you to send a packet directly from one of these to another one of these without any Wi-Fi access point involved. There's no IP addressing, there's no nothing, and you can connect up to 20 things together, which is more than you can do normally with these. And actually, realistically, you can actually connect more than that, because while normally it says it's 20 peers, but if you send stuff to something that's not a peer, it will just turn up. You can only fit 250 bytes of data in each of these packets, but that's fine. I only want to send tiny little messages backwards and forwards for what I do. So it's things like, I don't know, it might be a single sensor reading, it might be like a binary yes, no type value, very simple stuff. The problem with that is when it comes down to it, that is still just sending a message between two machines. If you're out in the real world, you've got 40 things out there, you don't know which things can speak to which other things because there's a tree in the way or a hill in the way, or somebody who was carrying this has walked 500 yards. It's got to be self-organising. So I had a look in the open source community to see what sort of things are out there that I can adapt. And I came across something from the hacker community in Germany. In Germany, there is a network called Freifunk, which is essentially a free mesh networking Wi-Fi thing with like a community thing. So the idea is people set up Freifunk nodes a bit like the Things network stuff that Tony was talking about, things like that. People can hop on it and it all meshes together and sorts itself out and you can get on the internet. Now, I can't implement that on this. There are many reasons why, but what I can do is I can steal their routing algorithm and kind of re-implement it. Their routing algorithm is amusingly called B.A.T.M.A.N, which I love. They also have other things called Robin and things like that. They have B.A.T.M.A.N associated names with all their stuff. But I stole their routing algorithm. So I've taken it and effectively from scratch re-implemented it. And it deals with a lot of the problems that you get with mesh networks where things move around and can reach each other one minute, can't the next. They can perhaps be asymmetric, so you can send to something, but it can't send to you. Horrendous problems in networking. The algorithm they've been working on for years deals with most of those issues. If I'd have tried to sort that out from scratch, I wouldn't have been able to deal with it. Now, normally, if you're sort of running B.A.T.M.A.N and Freifunk nodes and things like that, you also have the internet. For all the stuff I have, I don't have the internet. I'm in a field, there might not even be any 3G in that area. It's not always great where we are. So what I did was, you can't do DNS lookups and find things and all that kind of stuff. So I added some support for some sort of sharing of names to things. So you can give each of these things a name, and there's a shared clock signature, a little bit like NTP, like you might have on a thing. Not as accurate, not as detailed, but when you've got a network of all these now working together, they all know a certain common time signature within about, I don't know, 50 milliseconds, which is plenty good enough to say when this thing happens, something else happens, like set an alarm, and it's all kind of even. The messy thing is B.A.T.M.A.N, as written by the Germans, assumes that you can send out big broadcasts and find each other. So you can say, okay, a bit like I'd make a shout out on the Wi-Fi network and find each other. These things and ESP now don't support that, at least not in the library I have. So I've had to do a few kludges to make it work. but it works quite nicely. And if anyone wants to look at how about Freifunk and B.A.T.M.A.N 4, the URL is at the bottom of the page. So, I'm going to talk about algorithms now. Anyone interested in routing algorithms? I hope so. What B.A.T.M.A.N does is when it finds a node, which it does with a little bit of looking for a soft AP and then sharing each other, it continuously sends packets out, which it calls originator messages, and then anything that hears it forwards it on only once. And if it sees it coming back from somewhere, its own message, it goes, well, obviously that can hear me and I can hear it. And it gives it a kind of a value called transmission quality, which it bases off how easily it can hear it and how many echoes come back. And that, to be honest, is most of what's needed for it to work. So it's a very simple algorithm. And what happens is, if you want to talk across the network, so if you want to talk from A to B to C and onwards on here, you aggregate up how reliable that link is. So if you've got, say, from A to B is 100%, and then that's 80%, then what happens is it goes through, you kind of multiply all the sort of percentages together and say 90% of 80% is 72%, and you keep doing that, and you keep forwarding all these packets around, and the quality of the link goes down as they go around. The other thing it does as well is if there's two ways to reach something, you're best off going the short way if you can, so it does a little hop penalty. So if A can get to C directly with 100% reliability, but also to B and also B to C with 100%, you need some way to differentiate that path, and it applies a little penalty that says every time you forward it on, just apply a tiny little bit of penalty, so it's very slightly worse. And there's a bunch of complicated heuristics and things about applying penalties and certain little special cases and edge cases that deal with some really weird stuff. Not all of them I've implemented, but I've done some testing outdoors with large numbers of nodes and it all works. So, and my plan is to keep it really simple, because I did all this because I want to build stuff that talks to each other in the real world, and if I make it complicated, nobody will ever use it. Okay, if I make it hard. Now, when I had a look at P.A.N especially, it does work, but they don't really do the work for you, as well as being a bit flaky. I mean, you can encapsulate stuff as JSON in code, it's not hard, but they haven't done the work for you. You've got to put it all in, wrap all the stuff up. There's a lot of admin. So I deliberately made the work I've done on this supposedly easy to use. For anyone who's used to writing a little bit of C or C++ in Arduino, it should be relatively easy to use. So on the right hand here, that is the script that you need for a fully functioning mesh network node. So basically you include the library, you give it a name, so let's start out with a blank name and then adjust it to be based off the serial number of the device, set the name, tell it to start, and then in the loop, do a little housekeeping, and that doesn't even need to be done very often. As long as you did that about once a second, which is not very long in microcontroller terms, because these can do, well, as you know, real-time shifting of stuff around. This will just sit there and work, and you'll be able to pass on packets for other people, pass messages to things, push all stuff around. I've also built a little diagnostic tooling, because when I was trying to write it, it was really hard work seeing what was going on. So I've got a diagnostic tool built into the library, and if you just uncomment one line, it starts to spew stuff out on the serial port that you normally use for programming these with, so they can talk. So ideally, that should make it very easy to use. I haven't released it yet, so there you go. Now, that was a little rather pointless thing without an application. I'm going to try and demo it to you now, which could be interesting. So, what we've got, who would like a netbook? What we've got is I've written, somebody else want a netbook? This is a little IRC-like application that runs purely on the mesh that I built. Anyone want the third one? There you go. Or somebody. And so if anyone's ever used IRC, you should all be able to chat. Now, you should all be able to chat, and if I can get this working, I might also be able to show you on here as people type. Oh, sorry. It's IRC-like, so if you type /users, shows all the usernames. You can send private messages, so /message to the node name and then a message, /nick, change the name of your laptop. Don't all call yourself Spartacus, it doesn't check for duplicates. And if the terminals get messed up, hopefully, my problem is, and while that's going on, is that working?
Yes. Yep.
What I might very quickly do is plug in and try and do a little chat. Trouble is, I've damaged the USB port. Forget it, I won't do it.
Join, you only see the messages that you have since joining.
Yeah, it doesn't store anything. What's going on here? Right. Unfortunately, I can't demo it. I'll try and have you been able to chat. Pass it around. Just pass them from person to person. Send little silly messages backwards and forwards. Now, while that's going on, I should be able to show you. Just type, just chat.
We couldn't be able to get that one. Is it working? No, it's just that we couldn't get the Wi-Fi.
If I can work out how to move this between screens. And what you can see here is all the stuff that's going on in the background while these people are chatting. So, sorry, I can't show the chat on screen because this has died. And this is all the stuff that's going on behind. So when I was talking earlier about sending these sort of little originator messages, it's kind of finding stuff, talking all the time. Yeah. Did someone just restart something? Maybe, don't know. But yeah, so it sits there chatting away and shows you what's going on. From this, you can work out what the routes are and so on and so forth. So if someone's trying to create a project with this, they should be able to do it fairly easily. But there you go. So hopefully. And there's a chatbot there that every minute spits out a little bit of lorem ipsum. So you should get a little bit of lorem ipsum every now and then, which hopefully a few people have seen, which is sitting in the corner. So, what next? I'm going to try and port it to support the later chip that they released called the ESP32. The API is different, so it means quite a bit of work to do it. There are a whole bunch of things that are subtly different about it. Despite the fact that I've got that tool for showing what's going on and sort of like packet logging and saying who can talk to who, actually visualizing it. If you've got 40 things in a network and they can all talk to 10 other peers or 15 other peers, it's really hard to see what's going on. So I need to do something that actually exports it in a format you can import, make a few more example sketches, and actually release it so people can use it. What I actually want this for is in March, and hence the high vis, is we're running an event out in the arse end of nowhere with no connectivity and no mains, and we want it to have a whole bunch of stuff going on, all orchestrated together. So, for example, it's a game again, like all my stuff is. One of the ideas is that when the bad guy comes up, all the lights go out and everything stops working across the whole site. And so I need to be able to do that, so it's going to have a whole bunch of little things where all of a sudden when the bad guy turns up, all the power goes off and everything everywhere, and none of this stuff is joined up with cables. There's no internet, there's no Wi-Fi cabling, there's no mains power, it's all stuff powered off batteries, just lights strung up and things like that, and it will all die. And that's just one of the little bits of SFX we want to do. So that's why I put all this time into this, just for that silly little thing. But there you go. Now, no pie in that at all, but any questions? I hope it worked. I really wanted to show it on screen, but then I've managed to damage the USB port on my demo ones. Sorry? These things? Well, it depends what it's inside.
Well, when they're outside.
Everything's battery powered. Every single thing's battery powered.
Are you doing anything for power management or?
Right, yeah, power management's actually a really good question, because while all the time these are running, these are kind of using about 80 milliamps, which is a noticeable amount, and it'll flatten the battery. When you've got Wi-Fi clients talking to a conventional Wi-Fi AP, there's essentially a scheduling that goes on where the AP says you don't have to have your radio switched on until some point in the future. This all happens transparently on all our devices, we just don't notice it. And that happens very fast, in the order of milliseconds or even microseconds. I want to try and implement a similar thing with these so that they know they have a time slot when they can talk and be talked to, and that's why I started writing the time protocol to allow them to talk to each other. But I haven't got there yet. At the moment, the radios are always on, so you can always send and always receive.
Thank you.
Any more questions?
Have you thought about messages that get lost and stuff? Are you hanging on to messages? Hang on to messages and try and send them later on? Or?
It will know if it has been sent successively, but it won't actually do a retry. And I'm kind of, I'm in two minds as to whether to try and build that into the library or put it into, just say to people, look, you know whether it's sent or not, feed it back. Hiya.
I want to ask, if a person wanted to, like, was interested in doing that, and he wanted to do the similar thing that you did,
Yep.
and where would he first start off learning this code?
Starting the code stuff, I would start with any of the very basic introduction tutorials to Arduino programming for doing what I did. But a lot of this is kind of applicable to Pis as well, which I think it's harder to do sort of kernel programming in stuff like that, right? You're a man who knows about that. It's a much bigger, more involved task to do it on a Pi because there's a lot more going on. Whereas with a microcontroller, you're very in control of when the timing happens, just say, just send this packet to this MAC address now, which is how I've managed to do it. There's quite a lot of good tutorial stuff out there. However, the stuff about ESP.NOW, which I was talking about for this direct stuff, the documentation is rather poor, so I had to kind of find my own way and read the existing work, so it's quite hard. But in terms of doing ordinary Wi-Fi stuff with the ESP8266, there are a million tutorials about doing an IoT type project and things like that, and that would be a very good place to start because there are lots of things saying, okay, connect to a server somewhere, and then when someone sends a message from the server, something happens on this. And that would be a good starting point because that's actually where I started. I just then, for very specific reasons, kind of went down this rabbit hole of being entirely self-sufficient, needing no internet, needing no IP, needing no anything. Any more questions?
Can you have random nodes join and stuff like that?
None of this is programmed. The size isn't programmed. So if there's no authentication, this relies entirely on effectively. Yeah, there's no. The only hard limit on the number of nodes is running out of memory on this thing. 80K, I don't think it would actually run out of memory, and I've kind of hard-coded it down to 250 nodes. Biggest network I've run was 45. So I've got 45 of these things sitting around, and it kind of ticked away quite nicely.
How long does it take to program a new one? If someone rocks up with 10 of them, how would you?
Well, to put these just to do a chat node, I can program one of these from an existing script, just set the Arduino IDE going, and I'll do it in 15 seconds.
So if you have a big event going on, you just have people walk in.
Yeah, but the idea is these will be built into other props. So if people were bringing their own laptops, then you'd probably do it with real Wi-Fi and real connectivity and real apps that everyone has and things that will run on their phones. But this is for embedding in something else, to enable something else to do the machine-to-machine messaging and saying, when the bad guy turns up, turn off all the lights. Okay.
If you use it in real life, you use it like
It's one of my game things. It's for one of my game things again. Yeah.
With this IRC app, are you broadcasting a message to all the other nodes?
If you type it, it floods the whole network. If you just type it, if you do a private message, which I don't know if anyone's tried doing, if you try and send a private message to the other, it sends it across the network just to the individual node that it's getting to.
Don't they all receive it? It's just they don't process it.
They don't all receive it, no. Because the routing algorithm finds the most reliable and reasonably short route, it will pass through them all, but not all of them. Any more? There you go. Thank you.